Good evening to all. Am I audible? Can anyone message me? Just mention in the comment box. Am I audible? Is there any noise? Background noise is there? Is there background noise? Any noise along with my voice? Is there background noise? No? Okay then. Okay, I will start the class. So, if any issue is there, just mention in the chat box so that I will try to rectify it. So, per month electricity bill calculation for domestic appliances. So let us see how to calculate the electricity bill for the domestic appliances for 30 days. Approximately per month, we will usually assume per month consists of 30 days. Okay, of course there will be 31 days or 28 or 29 days, but approximately we'll consider 1 month as 30 days. So first of all, let us see briefly, not in detail, but let us see how electricity reaches our houses. Okay, because we want to calculate the electricity bill for domestic appliances. Let us see how electricity reaches our houses. So first of all, power is generated in the generating stations. Okay, it is generated in the generating station. This is a generating station. So there are different modes of generations. Okay, so power can be generated either in the nuclear power plant, thermal power plants, or solar power plant, or hydro power plant, or wind power plant. Okay, whatever may be the plant that is used, irrespective of which type of plant that is used. The main aim of those power plants is, or power generating stations is, to generate the electrical energy. So once the electrical energy is generated nearby to the generating station, this is our generating station. Here electrical energy is generated nearby to the generating station. Okay, there will be step up transformers. Okay, so this is a transformer. So this will step up the voltage level is increased here. Okay, so voltage level is increased, and higher voltage level is transmitted through these transmission lines. Okay, through these wires, you can see a wire here. So through the transmission lines electrical energy is transmitted, and while transmission, these transmission lines are placed on the electrical poles. Okay, so this is one of the three-phase transmission line pole, we can say. So and when the electrical power reaches, means electrical energy which is transmitted through the transmission lines, when it reaches nearby to the load sector, load means here you can see a house. So this is the load here. So when it reaches nearby to the houses, there will be substations where the voltage level is stepped down. So you can see here step down voltage, it is mentioned here. So transformer is used to step up the voltage level at the generating stations. Okay, at the load sector, nearby to the load sector, transformer is used to step down the voltage. Okay, it is used to step down the voltage. So now the voltage level is stepped down, it is reduced. Okay, and it is transmitted once again through the transmission line. This is also a tower, single phase tower. This is three-phase tower. Okay, so power is here you can see there is one more transformer which is placed on the pole. Okay, so this is the pole, this is the pole. Okay, this is the pole. On this pole a small transformer is fixed here. So purpose of the transformer is to once again step down the voltage. You can see here transformers on the poles step down electricity before it enters the house. Okay, so nearby to our houses also, if you see, if you go out of your house, somewhere nearby to your location, okay, somewhere transformers will be there. You can see the transformers nearby to your houses. So the purpose of those transformers which are located nearby to our houses is to step down the voltage. So the electrical energy is stepped down, and approximately around 220 or 230 volts, usually it is 230, okay, approximately 220 to 230 volts voltage is given to the domestic purpose or residential purpose. Okay, now in our houses there are many electrical appliances which consume electrical energy. So see, one more diagram I am showing you here. So this is our power plant generating station. So this is the substation nearby to the power plant. This is our substation nearby to power plant, and the voltage level is here in the substation. Transformers will be there where the voltage level is increased, and a high voltage is transmitted through this transmission towers. And nearby to the load sector there will be another substation where transformers will be there, where the voltage level is reduced and it is transmitted to the load. And once again, before giving to the load, once again its level, the voltage level is further reduced to the required voltage level of the load. Here load is the house. Okay, so the same thing I have repeated with two images. So in our houses, when electrical energy is given, there are many electrical apparatus. Where is my cursor? Yeah, there are many electrical apparatus which consume electrical energy. It can be a coffee maker, it can be a mixer, it can be a blender, toaster, or rice cooker, pressure cooker, many things. In your house, there may be many, what I have mentioned here, maybe few things, few electrical goods may be there in your house, some may not be there. Okay. In your house there may be an oven, there may be a dishwasher, a cloth dryer and or clothes washer, electric fans will be there. Okay, so many electrical appliances will be there in our houses. Okay, so which consume electrical energy. Okay, so the electrical energy consumed by this electrical apparatus, these apparatus which I am showing you here, which we use in our houses, all these apparatus won't consume same electrical energy. Okay, they won't consume same electrical energy. The electrical energy consumed by each apparatus will vary. Okay, so it will vary. So that means that the power rating of each appliance will be different. The power rating of each electrical appliance will be different. Okay. So power rating means it is the rating of the electrical appliance. Power rating means the rating of the electrical appliance which indicates the voltage at which the appliance is designed to work and the current consumption at that voltage. Okay, means power rating means, see here, so this is an electrical appliance. Okay, this is an air conditioner. You can see a label here which has been shown here. So if you carefully observe here, its rating, okay, its ratings will be provided here. Okay, what is the rating of this appliance will be provided. Similarly, you can see this is a compressor. So in this compressor, the voltage level, you can see volts. So it is 208 to 230 volts. Okay, and if you see, okay, it's a single phase, 60 hertz. I will take the laser. Okay, so 208 to 230 volts voltage, and its single phase, frequency is 60, 18 amperes. Okay, so this is some USA or Canada air conditioner, not Indian standards conditioner. Okay, so the ratings, voltage, current, power ratings will be provided. There will be a stickering provided on the electrical apparatus that we buy. And if we want to know the ratings, we can know the ratings by looking at the stickering that has been provided. So you can see this is an air cooler. So model number is given and its voltage, its rating, voltage rating is given 120 volts, frequency is given, or power rating is also given 900 watts. Okay, so this is a coffee brewer. Okay, BO, and if you see here, voltage rating is provided, current amperes, current rating is provided, okay, and it is a single or three phase, and a kilowatt rating is provided, power rating is provided, okay. So it is made in USA. All the specifications has been given. This is the sticker which has been sticked to the this coffee viewer. Usually it is stick at the back side or on the side of the apparatus. Okay, so we by looking at the stickers we will come to know what is the rating of the electrical apparatus. So rating of the electrical apparatus means the voltage at which the apparatus will is designed to work. Okay, means it can operate at this voltage. This coffee brewer can operate at voltage of 120 to 208 to 240 volts. Okay, and the current what is mentioned here 19.5 to 25.8. So at this voltage and this current, at this voltage and this current, this coffee brewer can operate. It can perform its operation properly for whatever purpose it has been designed, that purpose it can fulfill. Okay, so power rating is usually related to the power that this electrical apparatus is consuming. How much power electrical apparatus is consuming, usually power rating will be provided. If not provided, you can see the voltage and current rating. Just multiply the voltage and current values together, you will get the power rating. Okay, so by looking at the power rating we can say how much amount of electricity is required for the electrical apparatus to do the work. Okay, so usually the power rating of this electrical apparatus, it is usually denoted by watts W or kilowatts. The power rating of the electrical apparatus is usually denoted by watts or kilowatts. So what you people do is you can write down the heading and write down the first first four lines. From here to here, write down the heading and write down the first para. Write down the first para as quickly as possible. Up to here. Write the heading and write down the first para. Okay, I hope you are written. If you complete, just mention complete in the chat box so that I can proceed. So let us see the power rating of different appliances. I have the power ratings of few appliances. I have just quoted here some ratings here. So if you see here, so you can see the first term, washing machine. What is the power rating? It is 1.4 kilowatts. Okay, so usually it operates for how much period of time? 1 to 3 hours in our houses. Next, dishwasher, its power rating is 1.32 kilowatts and it usually operates for 1 to 3 hours in our houses. Hair straightener, its power rating is 0.0055 kilowatts and it usually operates for around 1 to 2 hours in our houses. Hair dryer, its power rating is 1.8 and its length of operation is around 1 to 2. Microwave, its power rating is 1.2 and it operates for around 3 to 5 hours in our houses. Computers, its power rating is low, you can see 0.15 kilowatts and usually we use them for a longer period of time, maybe around 6 hours to 12 hours. Okay, so it depends. When its power rating is 2.4 and it operates for 1 to 3 hours. And iron box, we to press the clothes. Okay, iron, its power rating is 2.4, and it usually it may operate for 2 to 4 hours. It depends on how many people are staying in a house. Okay, bread toaster, its power rating is low, 0.8, and it may length of operation depending on whether you it we sometimes use the bread toaster, sometimes we won't even use because mm, okay, because most of the Indians, they won't eat bread toast, isn't it? Very few people eat it. So electric kettle, its power rating is 2, and its length of operation is around 1 to 2 hours. It depends. Okay, it may be not it may be less than 1 hour. Okay, I have mentioned here some time length here, but it may be less than 1 hour. So if you consider one more, let us see one more list. So light bulbs. So if you see light bulb, incandescent bulbs, nowadays we won't use incandescent bulbs. Most of us, we are using the fluorescent bulbs. So if we are using incandescent bulb, its power rating is maybe around 60, 80 or 100 watts. Iron box, as I already mentioned at in the last slide, I have mentioned in kilowatts. Here I am mentioning in watts. Okay, 2400 watts. Fan, as a standing fan, it may be 70 watts. Water heater, 2000 watts. Electric blender, 350 watts. So these are all the apparatus which use electrical energy to operate, and these are all the power ratings. So for each and every electrical apparatus, power rating will be provided, okay, on the apparatus itself. See, this is a coffee brewer. So you can see at the back side, the apparatus power ratings are provided. Okay, air cooler, power rating is provided at the back side of this air cooler. Similarly, this is a conditioner, compressor of your air conditioner. So power ratings are provided here. Okay, so power ratings, the manufacturer himself will provide the power ratings. So here you can see few more apparatus. Water heater, power rating is around 12,000 watts. Okay, air conditioner, 3,300 watts. Okay, so washing machine, 3000 watts. Iron, 2000 watts, and so on. Okay, the power ratings of all these apparatus have been mentioned here. So many apparatus are there. Ceiling fan, its power rating is around 100 watts. Television power rating is around 180 watts. Okay, CFL, compact fluorescent lamp, its power rating is around 20 watts. And light emitting diode lamp, its power rating is around 10 watts. Refrigerator, its power rating is around 194 watts, and so on. Okay, so all these are the electrical apparatus. Each will have their own power rating. You can see, what you can see from this image is that the power ratings of all the apparatus is not same. Power rating will vary from one electrical apparatus to another apparatus. So definitely the energy consumed by each apparatus will vary. Okay, since the power ratings are differing from one another, definitely the energy consumed by each apparatus will vary. So let us see the energy consumption calculation. How energy consumption consumed by these electrical apparatus is calculated. Let us see that. So in order to calculate the energy consumption is given by the wattage of the device, means rating of the power rating of the device multiplied with the number of hours that device is operating. Okay, so number of hours that device is operating. So if you take a tube light, it may operate for around 6 hours to 7 hours. Okay, and if you take a ceiling fan, if you are staying in a house, so almost for 24 hours we won't even turn off the ceiling fan. So it operates for 24 hours. It depends. If you use a mixer grinder, so it may operate for 2 to 3 hours or hardly 1 hour. So it depends on for what purpose you are using the good. Okay, so it depends. The number of operating hours will vary. The number of operating hours will vary. Of course, wattage will also vary from one electrical appliance to another electrical appliances. Write down this energy consumption calculation and write down this formula. Energy consumption is equal to wattage into operational time. Operational time means operational hour is nothing but operational time. I hope you have written. So basic thing that we already know, the basic thing is, we know power is equal to what? V into I, means voltage into current. Okay, so we can write P is equal to V into I. Okay, so what is the units of power? Watts, current, amperes, voltage, volts. Okay, so I can say 1 watt is equal to 1 ampere. So wait, I will erase all the inks. I can say 1 watt is equal to 1 ampere into 1 volt. Okay, 1 watt is equal to 1 ampere into 1 volt, I can say. Now, if I convert this watt into kilowatts, kilo means 1000. Kilo means 1000. So 1 kilowatt is equal to what? 1000 watts. 1 kilowatt is equal to 1000 watts. Write down this. 1 kilowatt is equal to 1000 watts. 1 kilowatt is equal to 1000 watts. Just write it down. Okay, I hope you have written. Now, what is the definition of a unit? Unit is the electrical energy consumed in kilowatt hour. Okay, electrical energy consumed in kilowatt hour is nothing but unit. Write it down. Unit is electrical energy consumed in kilowatt hour is nothing but unit. Okay, so we know what is 1 kilowatt. Kilowatt we already know. 1 kilowatt is equal to 1000 watts. So kilowatt hour is equal to kilowatt into time in hours. Okay, while I'm explaining, you can note down in your notes. So kilowatt hour is equal to kilowatt into time in hours. So 1 kilowatt hour is equal to what? 1 kilowatt into 1 hour. Okay, 1 kilowatt is equal to 1 kilowatt hour is equal to 1 kilowatt into 1 hour. So once I can rewrite the above equation, 1 kilowatt hour is equal to what? 1 kilowatt means 1000 watt, 1 hour. Okay, so 1 kilowatt hour is equal to 1000 watt into 1 hour. Okay, 1 kilowatt hour is equal to what? 1000 watt into 1 hour. So 1 kilowatt is equal to what? I can write 1000 watt hour. Okay, 1 kilowatt I can write it as 1000 watt hour. So 1 kilowatt is equal to 1 unit. Okay, 1 kilowatt is equal to 1 unit, means 1 unit is equal to 1000 watt hour. I can say 1 unit equal to 1000 watt hour. What is meant by unit? Unit is the electrical energy consumed in kilowatt hour. So unit means electrical energy consumed in kilowatt hour. Just write it down. If you complete, mention complete in the chat box. Okay, I am proceeding. Okay, so we can say 1 kilowatt hour equal to 1 unit, that is equal to 1000 watts per hour. Okay, so if you want to define 1 kilowatt hour, we can say 1 kilowatt hour is the electrical energy consumed by electrical appliance of power 1 kilowatt when it is used for 1 hour. This is the definition for 1 kilowatt hour. Okay, you can, if you want, you can write it down. 1 kilowatt hour is what? It is the electrical energy consumed by the electrical appliance of power 1 kilowatt when it is used for 1 hour. When it is used for 1 hour. Okay, so to discuss about it with an image, I am showing you this image. Here I have considered one bulb. incandescent bulb, let us assume. Okay, so this is my electrical appliance. This incandescent bulb is my electrical appliance, and its wattage is given 100 watts. Okay, so its wattage, power rating is given 100 watts, and it is operated for time, okay, for a time of 1 hour. Okay, so this bulb, its power rating is 100 watts. It operates for 1 hour. Then the watt hour value, okay, watt hour value is what? 100 into 1. So its watt hour value is 100 into 1. Okay, so 100 watts into 1 hour we will get as 100 watt hour. Okay, 100 watt hour. Similarly, one more example, if you take same lamp, okay, same lamp, its power rating is 1 watt. It operates for 1000 hours. Okay, it operates for how many hours? 1000 hours. Then if you want the watt hour reading, you will get 1 into 1000, isn't it? You will get, where is my cursor? Yeah, so it is 1, sorry, here 1 into, sorry, I will write somewhere else. So 1 into 1000. One into 1000. What is it? Watt hour. Okay, 1 into 1000 watt hour. One into 1000 watt hour. So 1 into 1000 means 1000 watt hour. 1 into 1000 means what? 1000 watt hour. Thousand watt hour. Thousand means what? 1 kilo. So it is what? It is equal to what? 1 kilo watt. 1 kilowatt hour. 1 kilowatt hour. Okay, 1 kilowatt hour. What is 1 kilowatt hour is equal to 1 unit. Okay, so whenever you are mentioning power in terms of time, that is nothing but energy. Power in terms of time is nothing but energy. So kilowatt hour is nothing but energy, not power. Okay, so when you multiply power, watts, with hours, it converts into energy. Okay, so how much energy has been utilized? 1 kilowatt hour energy. 1 kilowatt is nothing but 1 unit, isn't it? Here we have mentioned here in this slide, if you see, yeah, in this slide, 1 kilowatt hour is equal to, watt hour is equal to 1 unit. Okay, so one more example. So here there is a lamp whose watt power rating is 100 watts. There are another lamps, 3 lamps whose power rating is 100 watts. Each lamp power rating is 100. Total how many lamps are there? 3. So 100 into 3 you will get 300 watts. Okay, so here only one lamp is there. So the lamp power rating is 100 watts. Here 3 lamps are there. Okay, 1, 2 and 3. 3 lamps are there. The power rating of each lamp is 100. So power rating of this lamp is power rating of first lamp is 100. Power rating of second lamp is also 100. Power rating of third lamp, this is our third lamp, power rating is 100. 3 lamps are there. The power rating of each lamp is 100. So 100 into 3 we can say. So what is the power rating of all these 3 lamps? 300 watts. Okay. Now this one lamp which is of 100 watts, it is operated for 9 hours. Okay. And these 3 lamps of 300 watts, they are operated for 3 hours. Okay. They are operated for 3 hours. So this one lamp whose rating is 100 watts, which is operated for 9 hours. So what is my kilowatt hour or energy consumed here? How much energy is consumed? How much units are consumed here? 100 into 9. Okay, 100 100 into 9. Okay, 100 into 9, you will get 900 watt hour. So convert that into kilowatt hour, it will be 0.9 kilowatt hour, means 0.9 units. 0.9 units. How many units are consumed here? 0.9 units. Okay, 0.9 units are consumed here. Similarly, if you go to the lower diagram, there are 3 lamps. Each lamp rating is 100 watts. Okay, so total 100 into 3, you will get 300 watts. And these 3 lamps are operated for 3 hours. So how many units are consumed here? So it is 300 into 3. Okay, it is 300. So my cursor is very sensitive cursor. So that's why if I press harder, it just so it is 300 into 3. I'm trying to write 300 into 3 here. So 300 into 3. Okay, if 300 into 3, you will get 900 watt hour. 900 watt means 0.9 kilowatt hour. That means 0.9 units are consumed here. Electrical energy consumed is 0.9 units. Okay, I can write again and again. Okay, whatever. 0.9 units, same, you can see, same amount of electrical energy is consumed. Okay, so depending on number of hours those electrical goods have been operated. Here, same, you can see, there is a single lamp here. There are 3 lamps here. Okay, where is my cursor? Yeah. So there is a single lamp here. There are 3 lamps here, isn't it? But this single lamp is operated for 9 hours. Whereas these 3 lamps, they are operated for 3 hours. So the amount of energy consumed by these 3 lamps and the amount of energy consumed by the single lamp, both are same. Okay. So it depends on how many hours the electrical goods have been operated. So see, you can see same amount of electrical energy has been consumed by the single lamp as well as 3 lamps. Why? Because the number of hours operated by the single lamp is more when compared to the number of hours operated by these 3 lamps. Okay. So let us see difference between power and energy. Simply kilowatt is the power, kilowatt hour is energy. So kilowatt hour is not power. Okay, so if you are multiplying, okay, if you are multiplying power kilowatts with time, if you are multiplying kilowatts with time, then the power becomes energy. So in this image you can clearly understand that. By looking at this image you can clearly see. So here it is kilowatt, here it is kilowatt hour. So kilowatt means power, kilowatt means power, whereas kilowatt means power, whereas energy means kilowatt hour. So here we have two electrical goods here. Okay, both are actually these are the electric vehicle chargers. This is one electric vehicle charger, this is one electric vehicle charger. The rating of this electric vehicle charger is 7.5 kilowatts. The rating of this electric vehicle charger is 60 kilowatts. Okay, so when this electric vehicle charger is charging the electric vehicle for 2 hours, so how much energy is consumed here? 7.5 into 2, you will get 15 kilowatts. How much energy is consumed? 15 kilowatts. And if this electric vehicle charges whose rating is 60 kilowatts, if it is operating for 2 hours, okay, if it is operating for 2 hours, then how much electrical energy it is consuming? 120 kilowatt hour energy is consumed. Okay, so depending on the number of hours the electrical goods operate, the energy consumption will change. Okay, the energy consumption will change depending on the number of hours the electrical good is being operated. It is turned on or it is being utilized. Okay. Are you able to follow? Just mention in the comment box if you are able to follow or not. Now let us see the calculation of power consumption, which is our actual topic. We were just discussing the basics before entering the actual topic. So calculation of power consumption of electrical home appliances. So there are some steps that are to be followed to calculate the energy consumption. Okay, there are some steps that are to be followed to calculate the energy consumption. So first step is we must check for the power rating. How much power rating is there? Okay, so for example, I have written 60 watts. So we must check for the power rating. Okay, if power rating is not given, what we have to do is, if power rating is not given, okay, another option. Okay, if power rating is not given, what we have to do is we have to see what is the voltage rating and current rating of the given electrical appliance. Okay, what is the voltage and current rating of the appliance? If you see the voltage and current rating of the appliance, you can measure power. What is the formula to measure the power? P is equal to V into I. Okay, simply by, one second, I will check whether I am online or not. Am I audible? Can anyone mention? Am I audible? Is there any disturbance? Is my voice clear or not? Is there any issue? Okay, then I'll proceed. So the steps that are to be followed. Once again. Okay. Okay, I'll proceed. So the steps that are to be followed to calculate the energy consumption, those steps are first of all we must see what is the power rating of the apparatus, electrical appliance. So power rating will be provided on the label that is sticked on your apparatus, electrical apparatus that you have been using. So the rating will be provided in watts. Okay, so for example, it may be written some 10 watts, 20, 30, 40, whatever may be. Here, for example, I have written 60. Okay, so or if power rating is not provided, voltage and current rating will be provided. Okay, voltage and current rating will be provided. So if you know the voltage and current rating, you can calculate the power. P formula is P is equal to V into I. Okay, formula is P is equal to V into I is the power rating. Okay, so now after determining the power rating of the apparatus, okay, you convert that watts into kilowatts. You convert watts into kilowatts. Okay, so you know how to convert watts into kilowatts. So 1 kilowatt is equal to 1000 watts. You already know. Okay, so 1 kilowatt is equal to 1000 watts means what? 1 kilowatt is equal to 1000 watts. That means what? 1 watt is equal to, can anyone mention in the chat box? 1 watt is equal to how much? If 1 kilowatt equal to 1000 watts, you just mention in the chat box. 1 watt is equal to how much? I am unable to write. How much? 1 watt is equal to 1 by 1000, isn't it? 1 by 1000 kilowatt. Okay, 1 watt is equal to 1 by 1000 kilowatt. If 1 kilowatt is equal to 1000 watts, then 1 watt is equal to 1 by 1000 kilowatts. So convert watt into kilowatts means whatever wattage value 60 by 1000. Okay, for example, if your watts is 60, if the power rating is 60, okay, so if the power rating is 60 watts, so write 60 by, if power rating is 60, write 60 by 1000. You will get kilowatts. Okay, 60 by 1000, you will get kilowatts. Now, after converting watts into kilowatts, what you have to do is find the energy consumed in kilowatt hour. Okay, so power rating in kilowatts into time in hours. Power rating in kilowatts into time in hours. So for example, 60 by 1000. For example, if it is 60, write 60 by 1000. Okay, so 0 will be cancelled. You will get 0.06 kilowatts. 0.06 kilowatts. You will get 0.06 kilowatts. Now in step 3, what is energy consumed? It is 0.06. It is 0.06 into number of hours that electrical apparatus that has been operating. So let us assume it has been turned on for 2 hours. Okay, so just multiply 0.06 into 2. Okay, you just multiply 0. 0.06 into 2, you will get 0.12. You will get 0. Sorry, 0.06 into 2, how much? You can write it in the chat box. If you are listening to the class, you can mention in the chat box. 0.06 into 2, you will get 0.12. Now, in order to determine the cost, total cost, simply what you have to do is, if 1 kilowatt, if the cost of per unit cost, okay, cost of your electrical energy consumption, if it is 0.194 per kilowatt hour, then you just multiply 0.12, 0.12, sorry, I'm unable to write properly. Multiply 0.12 with 0.194. Okay, multiply 0.12 into 0.194. Okay, so you just multiply it 0.12 into 0.194. So you will get around 0.023 rupees. Okay, so how much the cost is 0.023 rupees. So it's very low. So just for example, we are doing this calculation, nothing serious here. Okay, so we have considered only one appliance here. If there will be many appliances in our houses, so let us see the same for different appliances. Okay, let us see this for different appliances. In our houses, different appliances will be there. So let us calculate this. I'm not going to exactly calculate, but I'll tell you the procedure how to calculate our 1 month bill. 1 month electricity bill. I will tell you how to calculate the 1 month electricity bill. For that first step, okay, we must make the list of the appliances in our houses. Okay, what are all the appliances that are there in our houses? Just make the list of those appliances in a tabular column. So make the list of the appliances in a tabular column and write down their ratings, power ratings. Okay, make the list of the appliances and write down the power ratings. Yeah, write down the power ratings. So dishwasher, its power rating is approximately 1200 to 1500. Fridge 1400, 1400 approximately. Electric kettle 1200. Microwave 1000. Toaster 850. Stand mixer 300. Ceiling fan 120. So whatever in our houses, in your house, whatever electrical appliance is there, you can write down those appliances in the table and write down their power ratings. Okay, so first step, that's what you have to do. So I have considered some appliances and I have written the power ratings here in the tabular column. I have taken electric heater, its power rating is 4500. I have taken air conditioner of around 10,000 BTU, its power rating is around 900. Washing machine 800 power rating. Iron 1200 power rating. TV, plasma TV 200 power rating. Satellite dish 25 watts is the power rating. Compact fluorescent of 20 watts is around, its power rating is around 22 watts. And I have considered incandescent bulb of 100 watts. Its power rating is 100 watts. And LED bulb of 75 watts whose power rating is around 18 watts. Desktop computer 200 watts. Laptop 100 watts. If you have a printer, then printer power rating is 100. Smartphone, okay, we all have smartphone charge. Okay, smartphones, its charger power rating is around 6 watts. And if you have electric shaver, its power rating is around 15 watts. Okay, so these are some appliances which I thought we usually they will be available in our houses, and we may even have hair dryers. Its power rating is around 1500 watts. Weaving machine, if you have, it is 100 watts. If you have a vacuum cleaner, it's around 1000 watts. So you can write down whatever electrical appliances that are available in your house, and you can write down the power rating besides to it in the next column. Okay, after noting down the power ratings, okay, what we have to do is we have to calculate the power consumption of electrical home appliance per month. Okay, so let us calculate. So electrical appliance, write down the appliances. I have written only 3 appliances here. Okay, so what is the power rating? Write down the power rating in the next column. So next power rating in the next column is 120, and 120 for ceiling fan, incandescent bulb 100, electric shaver 15, and so on. You can write few more. Okay, you can write many things I have not written here. Okay, so quantity. Okay, number of ceiling fans. In our house, there may be at least 2 to, maybe depending on number of rooms that are available in our houses, there may be more than 2 ceiling fans. So I have considered 4 ceiling fans in a house. You can write your own, you can count the number of ceiling fans in your house, and you can write that number here. Then number of hours usage per day. Okay, how many hours of usage is there per day? So I have written 6 hours. Each fan will rotate for 6 hours. Okay, it will operate for 6 hours. Your wish. You can even write 24 hours if they are not turned off even once in one day. So you can write 24 hours. So I have written 6 hours. So now energy consumption per day. Okay, I have given some notation. E per day will be equal to power rating, okay, into quantity into number of hours usage per day. Okay, watts into number of hours. Okay, sorry, not number of hours. Number means quantity. Okay, so here number means quantity. Watts into quantity into number of hours they have been operated. So the wattage rating is for the ceiling fan is 120. How many ceiling fans are there? According to me, there are 4 ceiling fans. How many hours each ceiling fan is operated? For 6 hours. So into 6. So power rating into quantity, number of electrical appliances into the number of hours that electrical appliance is turned on. Supply is given to the electrical appliance. So 120 into 4 into 6 according to me. So just multiply these 3 terms. You will get the energy consumed per day. Okay. So if you multiply this, what do you get? 120 into 4 into 6. What is it? What is it? It is approximately 200 and, I'm sorry, not 200, 2000. 880. If you calculate this, I don't know whether this is right or wrong. You just mention in the comment box whether this answer is right or wrong. Now we have calculated energy consumed per day is 2280. So this 2280, I'm sorry, 2880. Okay, for 1 month, energy consumption per month. Per month means here I am considering per month 30 days are there. 2880 into 30. Just multiply it. 2880 into 30. So you will get around 86,400. Okay. You will get around 86,400. You just write it down in that last column. Okay. And for each and every electrical appliance, you calculate the energy consumed per month. Okay. And you add them all together, you will get the total energy consumed per month in watt hour. Okay. You will get total energy consumed per month in watt hour. So you will get total energy consumed per month in watt hour. You just write down that total here. Okay, simply you have to add all the energy consumptions by each and every apparatus per month. Energy consumption per month. You just take the total, you just add them and write it here. I have not written anything there. Why? Because I am not calculating anything here. Okay, you can do it. Okay, in here in the first column, write down all the apparatus that are available in your house, and besides to that, write down all the power rating of all the apparatus, and write down in the third column, write down how many number of ceiling fans are there in your house, how many bulbs are there, how many electric shavers. Usually electric shavers will be one or two, maybe. So it depends. What are all the electrical apparatus that are available in your house? Write down the number, how many are there. After that, how many hours they are being turned on. It can even be less than an hour. You can mention that. If it is for half an hour, mention 0.3. Okay, 0. Yeah, less than 1 hour means 1 hour means 60 minutes. So 0.3. Okay, 0.3 will be, or you can mention 30 minutes. 30 by 60, you will get a half an hour. Okay, 30 by 60. You can convert that 30 minutes into um, hours. So 30 by 60 you can write if you are operating any electrical good for half an hour. So write 30 minutes and you just divide by 60, you will get in hours. After that, you multiply this, multiply the power rating, number of electrical goods, and number of hours that electrical good was operating. You just multiply all these three, you will get some value. After that, multiply that value with 30. Multiply that value with 30. Okay. For each and every apparatus, you do the same. For each and every apparatus, you do the same. Later, you add all this. Okay. You add all this together and write the total energy consumed per month in watt hour. Okay. So just note down this table. Note down this table. Okay. So I hope you have written. Now, after calculating the total energy consumed per month in watt hour, now convert that in watt hour into kilowatt hour. So calculation of energy, total energy consumption per month in kilowatt hour. So already total energy consumed per month in kilowatt hour is equal to what? 1000 into total energy consumed in watt hour. So 1000 into watt hour will give us kilowatt hour. Okay, so 1 kilowatt hour equal to 1 unit. Here we don't have values, so we are simply writing it down here. So 1000 into kilowatt, 1000 into watt hour, you will get kilowatt hour. So 1 unit equal to 1 kilowatt hour. Therefore, total energy consumed per month in kilowatt hour is equal to what? Number of units. Sorry, where is my cursor? It is here. Total energy consumed per month in kilowatt hour is equal to what? Number of units consumed per month. Okay. Total energy consumed. So simply we are converting watt hour into kilowatt hour. So to convert watt hour into kilowatt hour, simply multiply here with 1000. Okay. And instead of writing kilowatt hour, write units. Okay. Total energy consumed per month in kilowatt hour is equal to number of units consumed per month. Okay. So just write. Okay. So even if you are unable to write now, you can write it down later after this class. Now let us calculate the cost based on the domestic tariff. So domestic tariff is provided by the electricity board. So number of units consumed. So we have just now we have seen how many number of units are consumed per month. Just now we have calculated. Okay, so number of units consumed. If suppose the number of units consumed is in between 0 to 100 units, then the tariff, it approximate values I have written here, it may be approximately equal to 4 rupees. Okay, if number of units consumed is 100 to 300, then the tariff value is rupees 5. If the number of units consumed is 300 to 500 units, then the tariff value is rupees 7. If the number of units consumed is 501 to 700, tariff value just consider 9 rupees. If the number of units consumed is 700 to 1000, then the tariff value is approximately 10 rupees. Means what is the rate? Rate of the cost of electricity bill will depend on what? How many units that we consume per month. Okay. Depending on the number of units that we consume per month, the rate will change. The rate of electricity bill will change depending on how many units that you consume per month. Okay, so I have one more sheet here. So you can see in this sheet, if the customer is consuming less than 5, if the number of units consumed is above 500, these are the rates. Okay, for the number of units consumed. So you can see here, if you want to see the difference, I can show you here. If you see here, when the consumer is consuming only 500, less than 500 units, and if suppose he consumes 100 to 200 units, okay, then the rate is around new tariff rate. You can see here, new tariff rate is around 0 rupees 2.35. If he is consuming more than 500 units, for the same rating, for 100 to 400 units, if he is consuming more than 500 units, for same rating of 100 to 200, you can see for the same 100 rating, the tariff rate has increased to 4. The value is, the tariff rate is 4.70. Okay, so thus as the slab varies, okay, up to 500, 0 to 500 is one slab, after 500 another slab, see, after above 500 is another slab, 0 to 500 is one slab. So if consumer consumes less than 500 units, the tariff rating, okay, rate of cost that he has to pay for the number of units he has consumed will vary when compared to the customer who consumes more than 500 units. The cost of the tariff rating or the cost of the electricity bill will change from person to person depending on the number of units that that person is consuming. Okay. Okay. So this is the tariff rating in per unit cost. Okay, this is the per unit cost. Tariff rate is what? It is the per unit cost. So if you want to calculate the cost of number of units, number of units that has been consumed per month, okay, at our house, it will be equal to the number of units consumed per month. Okay, number of units consumed per month into per unit cost. Means we have already calculated number of units consumed per month here, and you multiply it with, if suppose if you are utilizing around your number of units consumed is around some 400 units, then that will come under this category. So you have to multiply with rupees 7 to the number of units that has been consumed per month. Okay, so you can do this. You try to do this. I have explained in a simpler way as possible. You do this and you calculate the cost of the electricity bill in your house. Okay, per month cost. It's very simple. It's easy. So let us see some examples so that it will be easy for you to understand. So for example, you see here, I have considered an iron box, electrical iron, okay, with a heating element, okay, with a heating element of resistance 60 ohms, and it is connected across the supply voltage 240 volts is given. What you have to do is you have to calculate the electrical power produced in the heating element. How much power is P? We have to calculate electrical power, means P we have to calculate. We have to calculate the amount of electrical energy consumed, means E, by the iron box in how much time? In 20 minutes. Okay. So, mm, so I think I have changed it. I have changed the 20 minutes to 360 minutes. I'm sorry. I have changed it to 360 minutes. So, the amount of electrical energy consumed when the iron box is used for around more than an hour, isn't it? More than an hour. An hour means 60. So it's so let us assume it has 60 so that it will be easy for us. It has been used for 60 minutes so that it will be easy for us to perform the calculations. Huh? So okay, so it is being used for 60 minutes for 1 hour. The cost of the electricity given that Indian Power charges for rupees. So cost per kilowatt hour is given, that is 0.194. Okay, cost of electricity is given. Note down the problem. Note down as quickly as possible. Okay, then I hope you have written. Now, so here, first of all, they have asked us to calculate the power. So, what is the power formula? So, power formula P is equal to what? V square by R. Voltage is given, resistance is given. So, we have to use this formula only. We can't use P is equal to V into I. I is not given. So, what is voltage? 240 and resistance is 60. Okay. 240 square by 60, you will get 960 watts. Sorry. It is 900 and sorry. 960 watts. Okay, you convert that 960 watts to kilowatts. Okay, divide it by 1000, you will get 0.96 kilowatts. Okay, divide it by 1000, you will get 0.96 kilowatts. Next, they have asked us to determine the electrical energy consumed. Electrical energy consumed. How much electrical energy is consumed? So, power into time of operation. Power into time of operation. I'm going to change this. I have changed it in the question. It is 60. So, actually, 60 minutes means no need to write 60 directly. We can write 1 hour. So, 60 by 60, 1 hour. So, here it is 1. So if this is 1, this will become 0.96. 0.96. Okay, 0.96. This is it. I have made some changes here. So definitely this value will change. So this is it. So E is equal to P into energy consumed is P power into time of operation is 60 minutes. So 60 by 60 you will get 1 hour. 0.96 into 1 you will get 0.96 kilowatt hour. Now what is the cost of electricity? Cost of electricity is energy consumed into power charges. Power charges is given in the question 0.94. So 0.96 is the answer. You just calculate it and mention in the comment box. How much is the answer? What is the answer? 0.96 into 0.194. Okay, you will get approximately rupees 0 point, how much? 0.18624. So it's a very low value. It's okay. So here we have considered only one appliance, isn't it? We didn't consider all the appliances in our houses. So it's only one appliance, iron box. So the cost. So if it is operated for 1 hour, okay, so if that iron box is operated for 1 hour, so what we can see is that the cost of electricity consumption is around 0.18624. Yeah, yeah, it's right. Someone have mentioned. So, yeah, it's right. 0.18624 is the answer. This is it. I hope you have written. Let us see one more numerical problem. It is a bit typical when compared to the previous one. Write down the question. Okay. So calculate the electricity bill of household for a month having around 30 days using the following details. Electric unit cost is given around rupees 3.45. So per unit cost is given, that is 3 rupees 3.45. Okay. So electrical appliances are given here. Let us see what are all the electrical appliances that have been given here. 4 ceiling fans. Okay. 4 ceiling fans. 4 ceiling fans. 6 LED bulbs are there. One television set is there. One induction stove is there. Okay, so total 4 appliances are there. Okay, fan, bulb, TV and stove. Okay, wattage is given, power rating is given. The ceiling fan, per fan, each fan consumes 220 watts. And each bulb consumes 15 watts, television set consumes 250 watts, induction stove consumes 800 watts. Okay, so for how much duration of time they are being turned on? So the fan is turned on for approximately around 18 hours per day. Bulbs are turned on for 12 hours. Television is turned on for 8 hours. Induction stove is turned on for 4.5 hours. Okay, so just note down the question as quickly as possible. Now let us calculate the kilowatt hour consumption, means units consumption by each electrical apparatus separately. Okay, electrical energy consumption by each electrical apparatus separately. So let us proceed further. I hope you have written. Even if you have not written, you can write it down later from the video. So let us consider a ceiling fan power consumption per day. So here four fans are there. Each fan consumes 220 watts per fan. Okay, and it operates for 18 hours. So 4 into 220 into 18. Okay, 4 into 220 into 18. What is this? Okay, so I will just this is it. So ceiling fan, I will take the laser because I'm unable to. Okay, ceiling fan power consumption per day is four fans are there, 220 watts per fan power rating of each fan, and it operates for 18 hours. So 4 into 220 into 18, you just calculate it. You will get around 15840. If the answer is, if any of the answer is wrong by mistake, if my calculation is wrong, you can mention in the chat box. If the answers are, whatever answer that you get, you just mention in the chat box so that I will come to know that you people are listening to the class. Okay. So it is around 15,840 watt hour. So convert that into kilo, you will get 15.84. Similarly, consider LED bulbs. Power consumption per day. How many bulbs are there? 6 bulbs. And rating of each bulb is 15. For how many hours each bulb is operated for? 12 hours. So just multiply 6 into 15 into 12. 6 into 15 into 12, you will get 1000 watt hour. You convert that watt hour into kilowatt hour. So 1.08 kilowatt hour. I have given notation 50 for the above value. Kilowatt hour value I have given one notation. Here I have given two notation. Similarly, let us consider TV set. Okay, TV set is power consumption per day is around 250 watts, and it is turned on for 8 hours. So 8 into 250, you just multiply it, you will get 2000 watt hour. Okay, so if you are getting 2000 watt hour, just convert that into kilowatt hour. Just write it down quickly. So simply you have to multiply number of the quantity number with the power rating into number of hours. You will get kilowatt hour. You just calculate and check the answer. Give notations 1, 2 and 3. Okay, I'm just moving to the next slide. Similarly, similar to this case, one more apparatus is there. What is it? Stove. Stove set is given. Power consumption per day is given. So here, the rating of that stove is, so rating of this stove is 1800 watts. It is operated for 4.5 hours per day. So since it is operated for 4.5 hours per day, so multiply 1800 with the 4.5, you will get 8100 watt hour. So you just convert that watt hour into kilowatt hour. So divide it by 1000. 8100 by 1000, you just divide it by 1000, you will get 8.1 kilowatt hour. So consider it as equation number 4. So we have calculated the kilowatt hour um, rating of each and every electrical apparatus which has been mentioned in the question. Now to get the total kilowatt hour per day, energy consumption in kilowatt hour per day, total energy consumption in kilowatt hour per day, you just add all the values 1, 2, 3, 4. Okay, you'll get the total kilowatt hour energy consumption per day. So how much is it? It is 15.84 plus equation 1 plus 2 plus 3 plus 4. Total energy consumption per day. 15.84 plus 1.08 plus 2 plus 8.1. You just add it, you will get 27.07 kilowatt hour. Okay, you'll get 27.07 kilowatt hour. Note it down quickly. Okay, I hope you have written. So now we have calculated total energy consumption in kilowatt hour per day, but we want the total energy consumption per month, that is for 30 days. So per day, whatever value that you have got, you just multiply with 30. So 27.02 kilowatt hour into 30, you will get 810.6 kilowatt hour. So total power consumed in 1 month. Okay, or we can say instead of using the word power, it's better to use the word energy. Total power consumption, I can say, per month, or energy consumed per month. Okay. Total electrical energy consumed per month. Okay. Total electrical energy consumed per month is around 810.6 kilowatt hour. This is the total electrical energy that has been consumed per month. Now let us calculate the LCT bill. LCT bill is what? Total electrical energy consumed per month into cost of 1 electric unit. So how much is the cost of 1 electric unit? It is 3.45, which is mentioned in the question. Okay, if you go to your question, it is mentioned electric unit cost is rupees 3.45. So it is mentioned in the question. So you just see here the total electricity bill is equal to total energy consumed in 1 month into cost of 1 electric unit. So how much is the energy consumed per month? 810.6, and what is the cost? 3.45. So you just multiply it these two, you will get rupees 2796.57 approximately. You can round it off, you will get 2797 is the electricity bill for these electrical goods. Just write it down. So I hope you have understood. Even if you have not understood, later you can go through this video once again to understand the concept. If you have not understood the concept, you can go through this video later. Okay, so it is it's already 8 o'clock. I will try to conclude within few minutes. So let us see one more small topic and I will conclude this topic. So tariff. Tariff is the electrical energy that has been generated in the generating station. Okay, that is delivered in large number of scale at a reasonable rate. Okay, so whatever electrical energy that has been generated in the generating stations. Okay, so here you can see here. So this is a power plant, isn't it? There are different types of fuels that are used in the power plants. It can be coal, it can be water, it can be wind, okay, or it can be nuclear power plant. The power plant can be of any type. So the power that is generated and the voltage is stepped up at the substation through the transmission lines. It is transmitted, okay, transmitted and it is given to the after transmission nearby to the load sector. There will be a substation where the voltage level is stepped down and it is distributed to different types of loads. You can see houses here, you can see a factory, and you can see a commercial building. So there is another image. So here you can see generating station. So here you can see the voltage level is stepped up here, 3 to 36 kilovolts of voltage. Here, this is a transformer, step-up transformer. The 3 to 36 kilovolts voltage is stepped up to 500 kilovolts. Okay, so whatever power that is generated here, electrical energy, its voltage level is around 3 to 36 kilovolts here, and it is stepped up to 36 to 500 kilovolts. Next, it is transmitted by these transmission lines. Okay, and it reaches the okay, it reaches nearby to the load sector somewhere. There is a substation here in between. In this substation, voltage level is stepped down from 500 to 132 kilovolts. So voltage level, it has been stepped down here from 500 to 132 kilovolts. Again, it is transmitted here by the transmission towers, and nearby to the load sector, there is a substation. You can call it a distribution station. Okay, where the voltage level is further stepped down to 13 to 2 kilovolts. 13 kilovolts or 2 kilovolts. This 13 to 2 kilovolts, okay, it is directly given to some industrial customer. Okay, so to some industrial customer, this is given to some industrial customer. I will take the laser. So to some industrial customer, 13 to 2 kilovolts is given. Further, it is transmitted through the transmission lines, and there is one more distribution transformer where the voltage level is further reduced to 220 volts, and it is given to the residential customer. Residential means houses. So see here, power is generated in the generating station. The voltage level is stepped up by the step-up transformer, and this supply voltage is transmitted through the transmission lines. Again, in between, there is a substation where voltage level is stepped down from 500 to 130 kilovolts. Again, it is transmitted, and nearby to the load sector, there is a distribution transformer where the voltage level from 132 is stepped down to 13 to 2 kilovolts, and it is given to the industrial customer. And again it is transmitted, and again there is another distribution transformer which step down that voltage level to 220 volts, and it is given to the domestic purpose. Okay. Now you can see here there is a power station. One more image I am showing you. A power station. Power is transmitted by the transmission towers. You might have seen this sort of towers besides to the highway roads. Okay, these are transmission towers. From here it is transmitted to the loads. Okay, and the loads can be offices, the load can be a village, the load can be a factory. So there are different types of loads. Okay, so since the loads are different types, the electrical energy consumption by these loads will also vary. Hence the rate of the cost at which the electrical energy is supplied to different types of loads, the cost will also vary depending on what type of load is it. So we didn't discuss anything about this tariff. Let us see what is meant by tariff. Tariff is the rate at which electrical energy is supplied to the customer. The rate at which electrical energy is supplied to the customer is known as tariff. Okay, so the rate at which electrical energy is supplied to the customer will not be always same. Why? Because the customer can be a factory, customer can be any office, commercial building, customer can be a domestic house. Okay, so depending on which type of customer is there and how much electrical energy demand is there from that particular customer, the rate will vary. Okay, the rate will vary. So what is tariff? Tariff is the rate. Write it down. What is tariff? Tariff is the rate at which electrical energy is. Rate means price, rupees, price, cost. Okay, rate means cost. So the rate at which electrical energy is supplied to the customer is known as tariff. Okay, so we can even say tariff is the tax that the government imposes on the imports, usually with the aim of boosting domestic production and demand. This is another definition for tariff. So we can even say tariff is the tax which the government imposes on imports, okay, usually with the aim of boosting domestic production and demand. So in order to boost the domestic production and demand, they impose this tax is imposed on the imports, means which are imported from the other companies. If goods are imported from the other companies, okay, they have to pay the tax. Okay, so this will help to boost the domestic production and demand. Okay, now there are some inclusions of tariff. So let us see what are all the inclusions are there in the tariff. So the inclusions of tariff are, so see, power is generated in the generating station, later it is transmitted, later it is distributed. So okay, power is generated, transmitted and distributed to the load. Okay, three operations are being performed here: generation, transmission. If you remember in the first slide I have shown you, first slide. So where is it? Generation, transmission and distribution. Means power is generated, after generation it is transmitted, and later at the load it is distributed. Okay, so there are different types of loads. How many types of loads are, you can broadly classify them into three types: industrial loads, commercial loads, and domestic loads. Okay, industrial, commercial, and domestic. So I will show that in this image. Okay, load can be customer or load can be domestic. This is domestic. See here, offices are there. Offices. Offices means commercial load. Here you can see a factory. Okay, so industrial. So loads can be industrial type, commercial type. These are the industrial. These are industrial type. These are the commercial type. Houses means domestic type. So loads can be different types of loads. So since loads are different types of loads, the rating will also be different. So power is generated, transmitted, and distributed. So in order to generate power, we have to spend some money, isn't it? We have to spend money to generate power. So that money has to be recovered. Okay, that money has to be recovered. So tariff includes the recovery of the cost of generation. Okay, recovery of the cost of generation of electrical energy in the power station. Whatever cost that they have spent to generate the electrical power, that cost has to be recovered. Next, tariff includes recovery of the cost of capital investment in transmission and distribution. They have to transmit the power, later they have to distribute the power. So how much they have spent, how much money they have spent for the transmission and distribution, that has to be recovered. And one more thing that tariff includes is the recovery of the operation and maintenance of the electrical energy. So electrical power is generated, transmitted, and distributed. There will be many equipments at the generating station. There will be equipments at the transmission system. Will also have equipments like towers, insulators will be there, protective devices will be there. At the distribution station, substation transformer, step down transformer will be there. Okay, so all these are to be properly maintained. Okay, so for that they have to spend money. So how much amount they are spending for operation and maintenance of the electrical appliances, that amount also they have to recover. Okay, so and as well as they must get some profit, isn't it? For without any profit, if they are simply generating and distributing the electrical energy, then that is of no use. Okay, so all these factors are included in the tariff. So tariff includes much. What does this tariff include? It includes how much cost, means how much money is spent for generation, that has to be recovered. How much money that is spent for transmission and distribution, that has to be recovered. How much money that is spent for operation and maintenance, that has to be recovered. And some profit is also expected. Okay, for doing all these things, they, of course, after performing a task, there must be some profit to the electricity board people, whoever is generating, transmitting, distributing, they should get some profits. Okay, so including the profit, all these factors are considered in tariff. Okay, so there are different types of tariffs. Okay, among different types, one type of tariff is two-part tariff. Okay, among different types of tariffs, we are not going to discuss the types of tariffs now. So among different types of tariffs, one of the tariff is two-part tariff. One second. Okay, I was just checking whether I'm in the class or not. So one of the type of tariff is two-part tariff. So two-part tariff means if the customer who have appreciable maximum demand, if the customer has a maximum demand of electrical energy, for such customer, two-part tariff method is employed. So maximum demand of electrical energy will be there by these industrial factories. They demand maximum amount of electrical energy. Okay, so their per unit cost will also vary from domestic purpose. We pay very less when compared to the factories, so their demand will be very, very large. Okay, so for such people, okay, two-part tariff is employed. Okay, two-part tariff is employed for those loads or customers who have maximum demand of electrical energy. Okay, so when the rate of electricity energy is charged on maximum demand, then the customer and the units consumed is called two-part tariff. Okay, so definition for two-part tariff is given here. So when the rate of electrical energy is charged on maximum demand of the customer and the units consumed, that is known as two-part tariff. Just write it down. What is meant by two-part tariff? Write down this. Hope you have written. Okay. So in this tariff scheme, that is two-part tariff scheme, total cost is charged to the customers consisting of uh, it consists of two components. One is fixed charge, other one is variable charge. Okay, fixed charge will be there plus variable charge will be there. So the total cost will include the fixed charge and variable charge. So let us assume A represents the fixed charge, B represents the variable charge. Okay, A represents what? Fixed charge. B represents variable charge. Okay, so A means charge per kilowatt of maximum demand. B means charge per kilowatt hour of energy consumed. Okay, B means charge per kilowatt hour of energy consumed. A means charge per kilowatt of maximum demand. So this is our two-part tariff. Okay, so the total cost of two-part tariff is A plus B. A is in kilowatts, B is in kilowatt hour. Okay, A means A is the fixed charge, B is the variable charge. A means charge per kilowatt of maximum demand, B means charge per kilowatt hour of energy consumed. Okay. So if I want to determine the total loss charged to the customers, okay, if the total cost charged to the customers, if I want to determine, simply it can be obtained by multiplying what number of units consumed and rate per unit. So simply you multiply, okay, just multiply number of units consumed into rate per unit. You will get the total cost charged on the customer. Okay. So fixed charges will depend on maximum demand of the customer. Okay. Whereas running charges, they depend upon the energy consumed by the customer. Fixed charge will depend on what? Maximum demand of the customer. Running charge will depend on the how much energy that the customer is consuming. This fixed charge is usually due to the generation, transmission and maintenance. Okay. Fixed charges due to the generation, transmission and maintenance. Okay. So in our electrical bill, if you observe, there will be mentioned, we never notice that fixed charge and variable charge. But of course, it is for the high demand people, that is for industries, not for our household. So some bill is there. So you just go through your bill. If something is mentioned, you just check whether fixed charge, variable charge is mentioned or not. Usually it is applicable only for the high demand LCT. High demand LCT is for the industrial purpose. Now let us see LCT bill with tax for especially for this two-part type. Okay, for two-part type tariff. Okay, so how LCT bill is calculated. So here again they will consider fixed charge and variable charge. So total LCT bill same, fixed charge plus variable charge A plus B plus tax. Okay, tax will be included for two-part type tariff. So okay, so where A is in kilowatts, B is in kilowatt hour, same plus, but there will be an extra tax term. Okay, tax rate will differ. Okay, you can see here, this is a bill here, tax is mentioned here, and even penalties if electricity bill is not paid on time, it is also mentioned here. Okay, so let us see how this electricity bill is calculated. So for example, if I have 1 kilowatt, for 1 kilowatt rate is around rupees 85, and above 1 kilowatt for industries, for high demand loads, okay, high demand customers. For 1 kilowatt, rate is around 85, and for 1 kilo, above 1 kilowatt, okay, for above 1 kilowatt, the rate is 95. Okay, so if the high demand customer is consuming up to 1 kilowatt of electrical energy, then the rate will be around 85. If the high demand customer, that is industries, if they are consuming above 1 kilowatt, then the rate is around 95. Okay, so if this is the case, let us consider the load is around 3 kilowatts. Okay, load is around 3 kilowatts. So you can divide this 3 into 1 kilowatt plus 2 kilowatts. Okay, you can divide this 3 into 1 kilowatt plus 2 kilowatts. So 1 plus 2 is nothing but 3. Okay, total load is how much? 3 kilowatts. I have divided 3 into 1 kilowatt plus 2 kilowatts. What is A? A is the fixed charge. Okay, so A is the fixed charge. So here rate is given. For fixed charge, rate is given. For 1 kilowatt, what is the rate? 85. So for 1 kilowatt, multiply 1 with 85. Above 1 kilowatt, how much is above 1 kilowatt? 2 kilowatts here. Multiply 2 with above 1 kilowatt, what is mentioned here? 95. So 2 with 95. So 1 into 85 plus 2 into 95, you'll get rupees 275. So the fixed charge is around 275 rupees. Now let us see the variable charge. So variable charge is equal to number of units consumed into rate per unit. Okay, number of units consumed into rate per unit. So number of units consumed, let us assume that example, let us take an example. Let us assume for 0 to 50 units, the tariff rate per unit is 4 rupees, 4.1. For 50 to 100 units, it is 5.55. For 100 to 200, rate per unit is 7.1. Okay, so this is the rate per unit for variable charge. So here, let us assume the number of units consumed is 120 units. So if you see here, minimum he has mentioned 0 to 50. Okay, 0 to 50 he has mentioned. So this is 50, this is 100. Okay, this is 50, this is 100, this is 200. So up to 50, what is the rate? Up to 50 rate is 4. So divide 120 into 50. Okay, 50 plus 50 is 100. So this is 100. Okay, 50 plus 50 is 100. For 100, what is the rate? 5.55. Next, leftover is 20. So above 100, 120. 120 lies between 100 to 200. What is the rate? 7.1. So divide 120 into 3 parts. 50 plus 50 plus 20. Okay. So now consider these rates, above mentioned rates. Consider these rates, rupees 4.1, rupees 5.5 and 7.1. So for first one, for 50, rate is 4.1. For next 50, that is 50 plus 50. 50 plus 50, that is 100. For 100, what is the rate? 5.55. 50 plus 50 plus 20. What is the rate? 7.1. Okay, for 120, rate is 7.1. Okay, so for 120, rate is 7.1. For 50, for 100, rate is 5.55. For 50, rate is 4.1. Isn't it? For 50, rate is 4.1. For 100, rate is 5.5. For 200, rate is 200. Our case, it is 120. For 120, rate is 7.1. So just multiply and add, you will get 624. So now, what is the total electricity bill for the high demand loads? It is A plus B plus tax. So 275 plus 624 plus tax. Okay. So tax will be high for the high demand loads. It won't be same as the domestic purpose. Okay, our tax will be almost negligible. Okay, our taxes will be almost negligible. Means domestic purpose taxes will be almost negligible, very low. Okay, so I got a chart from the Google. I just searched and I got this in Andhra Pradesh for domestic loads. This is the tax rate for commercial loads. This is the tax rate. So for some state, Assam, this is the tax rate for commercial, for domestic and commercial. For Bihar, this is the tax rate, and for Chandigarh, this is the tax rate. Okay, tax rates from state to state they vary. Okay, so this is how electricity bill is calculated per month for the given system. Okay, so if you have any confusion, if you are unable to follow, you can go through this video later on. If you have understood the concept, you just click on the like button. Okay, so if you have not understood, you just once again go through this video so that you will be able to understand. It's very simple and easy, nothing much complicated here. Okay, it's a very simple concept, nothing complicated. Okay, then I am concluding.